Let me welcome whoever's viewing to today's webinar from the SIG HPC Education Program. I'm Steve Gordon. I'm currently the Secretary Treasurer of the chapter. And before we get started, I want to just share with you how we're going to accept the questions from this broadcast. And so if you go to this particular website, which is SIG HPC Education hosting.acm.org, Ajax chat, you can sign in with your name or nickname in parentheses with no password. Then you are able to add stuff to the chat window, and we'll use that to accept questions throughout the broadcast. We'll hold most of them until the end, but I'll be watching that as we go along. So that's how you will be able to see or ask questions of the presenters. So without further ado, I'd like to introduce Alan Chalker from the Ohio Supercomputer Center, and he's going to talk about the AweSim modeling program and what it's about. So Alan, I'm going to turn it over to you.
Okay, thanks Steve. And I'm going to share my screen here. And there we go. Okay, so I'm going to talk a little bit about the AweSim program, but first, just real quick, the agenda of what I'm going to cover over the next 45 minutes or so. If I can get my slide to advance correctly. There we go. I want to talk a little bit about OSC and then AweSim. This presentation that I'm giving would normally be given to potential clients that we're out there talking about. So there's a section in it that talks about what modeling simulation HPC is. I'm going to skim over that very quickly because, of course, my assumption is that everybody that would be listening and attending the SIG HPC education group would have a pretty good understanding of that. So a lot of this of why you should be interested and who is using it will probably make sense and become a refresher for everybody, but I think it'd be helpful to show how we present this and portray this to potential clients and others that we want to get engaged in it. So let's go way back, and I've got to tell a story here. And like all good stories, there has to be an obstacle to overcome. And if you look at the history of supercomputing in the US, in the early to mid 80s, the National Science Foundation put out a call where they want to establish a series of national centers. A group of Ohio faculty members got together and had submitted a proposal against that RFP. As I'm sure many of you that are listening know, there were 5 national centers that were established early on, and they're shown here on the screen. Obviously, there's not one from Ohio that's on that screen. And the Ohio proposal was not selected for funding. And just as a little tidbit, I tend to try to put little interesting images and stuff in the background on my slides to make them a little bit less boring. That cray that you see there is, I believe, the first cray that was at NCSA there. So those faculty members from Ohio that didn't get approved by NSF took that proposal and basically said, well, we're going to take it and see if we can play on our home court. And they went to the Ohio governor and the General Assembly at the time and convinced them to fund that proposal. So the next year, in 1987, the Ohio legislature established OSC, the Ohio Supercomputer Center. And it was June 30th, 1987, House Bill 161, I believe it was. If you do the math, we're almost at our 30th anniversary. That's coming up in just a few months from now. And what you see there on the screen is in the entirety the legislative language that established OSC. The important, interesting thing about this is actually the second sentence, the very middle, which is something that was added and was not really present in the original proposal to the NSF. Obviously, these faculty members were initially intrigued and thinking about this from an academic standpoint, but the assembly and the governor said, you know what, yes, but we also want this to be accessible to private industry as appropriate. We want this to be an economic development asset for the state. So that little sentence is what really set into motion a whole series of events I'll cover here that somewhat differentiated us from many of the other centers that are out there, and that we are a resource both for academia and for industry, and empowered as such by our legislative charter out there. And if you notice then a few months later in the lower right hand corner, I've got a resolution from the Ohio Board of Regents, which now is called the Ohio Department of Higher Education. And if you notice that the very explicitly said it is a statewide resource for the universities and industry in Ohio. So if we kind of jump forward then, since basically day one, we were involved with industry, and we actually in 1988, the next year, had our first commercial client. That happened to be a company called Battelle. We charged them the outrageous rate of $1,000 per core hour on that Cray YMP that you see there in the background. Whereas nowadays it's pennies per core hour. So, but we've had a lot of companies that we've worked with over the years. But for many, many years, for at least about 15 years or so, it was word of mouth, and it was primarily big industry here in Ohio. Battelle, Procter & Gamble, things like that. So if you fast forward to about 2004 or so, our former executive director, Stan Ahalt, who's now at Renzi, North Carolina, gave a keynote address to the SC 2004 conference in Pittsburgh, where he came up with this term and this concept of the missing middle. And this is a chart from around that time frame. It wasn't actually shown at the address, that kind of explained that, hey, you've got differing levels of computational challenge, and you've got differing levels of users, but there's this gap. And that gap is really between the individual researchers and the engineering groups. And then there's also an underutilization by large industry in certain areas. So we called that the missing middle, the small and mid-sized business and the supply chain. And OSC at some point shortly thereafter branded our program for industrial engagement as blue-collar computing. The idea being that it's supercomputing for the rest of us, for that missing middle. So we had a variety of programs and projects under that blue-collar computing moniker that then around 2011 or so accumulated in a national public-private partnership called Endemic, the National Digital Engineering Manufacturing Consortium. And this was a partnership between several large OEMs, you can see there on the screen, several computing providers, and both state and federal government agencies that all kind of kicked in various amounts of funding and cost share and things like that. We did win an HPC Wire Award in 2012 for that program. The idea was to really demonstrate the value of modeling simulation to the supply chain. And we had 20 different demonstration projects. In the course of doing those projects, what we ended up doing is we ended up developing several what I call portals. And the idea is that for many of these small non HPC savvy businesses or users, it's very intimidating to get access to a supercomputer and to figure out what to do. There's a pretty high barrier to entry. So we worked on lowering that barrier to entry via web-based, we'll call them portals or smart apps. The first one we did was in 2007 with an organization called Edison Welding Institute, and it was a welding simulator called Weld Predictor. You see a picture of it in the background there on the left. We also did one with an organization called Polymer Ohio that was provide access to polymer-specific software, things like injection molding simulation, extrusion simulation, stuff like that. And we found over the years that those portals seem to lower the barrier to entry. We definitely, as shown on the table here, with the welding portal in particular, we were enabling users with a lower level of educational background regarding welding to solve problems in fraction of the time that it previously took doctorate level expertise on there. So these were very educational. Most of these were kind of one-off, and over that period of time, that 6 years or so, we realized that it really wasn't scalable to create these things one-off every time somebody came to us. So what we did then was we transitioned to a model of having what we call a platform, where we created a platform that people could create products on. They could create portal software, stuff like that. So the vision that I used to like to tell people is that we're trying to do for supercomputing what Apple and Google did over a decade ago for smartphones. And that smartphones existed. We had Palm Trios and things like that, and Blackberries. But to really mainstream them, you have to create this whole ecosystem. You have to create a hardware that's accessible and affordable. You have to also create a ability for people to go and find products, an app store, so to speak. But most importantly, you get to create the whole training and app kits and software development tools to allow other people to create products on your platform. So the summary statement is that I want there to be an Angry Birds equivalent killer app for supercomputing. I know that I'm not going to create it. Nobody here at OSU is going to create it, but we want to facilitate and enable people to create it using tools. That first tool that we created was what's called On Demand, and this is now On Demand, which I will demonstrate here in a little bit, is kind of our interface for clients to come in via web-based. They can still come in via traditional SSH X Windows, but many of them are now coming through this web interface. And then that translated into the AweSim program that I'm going to talk about a little bit more detail here. On Demand, I'll point out, has received some NSF funding via one of the NSF SI squared programs, and we actually have something called Open On Demand that is now available for deployment at other centers, and several other centers are looking at it. I know we're working very closely, for example, with Oak Ridge, and they're looking at setting up on their CADES platform. If you're interested in that, feel free to reach out to me. We have, again, it's open source, paid for by NSF, and we would love to have people engage and try it out. So to kind of summarize this whole thing, what really happened was we went from this blue-collar computing concept that was just out there to a public-private partnership, a federal public-private partnership that was called Endemic. After a few years of Endemic, the funding kind of ran out. We were looking at what to do, and that transitioned for a sizable portion of the Endemic participants into what was called AweSim, which was funded more by the state here in Ohio, and I'll talk about that here a little more in a second as well. So now I'm going to jump from the history that I don't normally necessarily go into to what I would talk about with a potential client, and talking about why you'd be interested in Endemic, why you'd be interested in modeling and simulation, and this whole thing we call our modeling and simulation leadership workshop, and what that involves. So the first question is, who is AweSim? People come and the AweSim brand is just a catchy way, because we found that when we go and talk to people and say, hey, I'm from the Ohio Supercomputer Center. They're like, oh, okay, so you're a university professor. Well, yeah, we don't really have interest for you. When we position ourselves more as a business or a brand, that really is helpful to opening the doors and talking to people about, hey, we're a service, something that we can engage with. They know how to do that, as opposed to thinking about it purely in academic terms. So what do we provide? Well, we provide very carefully selected language, competitive solutions for simulation-driven design via online apps and tools, training, and expertise. We try to stay away from using the word supercomputing because that's scary. Even HPC is a little bit scary for people. So you'll notice I use the terminology modeling simulation a lot. So AweSim started as this public-private partnership, and it consisted of Ohio-based organizations as well as industry that kind of came out of the endemic national public-private partnership into a more regional one. Everybody kind of kicked in there. That was about 3 years ago. Now that first round of funding that we got has expired, but we're continuing to operate AweSim as a program within OSC. The industry isn't really kicking in cost share anymore, but they are still engaged in a variety of ways, and I'll talk about that here in a second, what that looks like on there. But it is very much still a brand and a program that we're offering up that fundamentally offers up 5 different products and services. And those are listed here. It's expertise, software, HPC, apps, and app kit. We have found that the order that we present these in is very important when we're talking to industry. Most of the people we talk to don't really know where to get started, so they're looking for someone to help tell them what it can do and how to get started. So that's why we really portray the expertise at the top and say we can bring to you a team of experts. And then the next level down is software. Then it's somewhat rare for people to come in and say, yeah, get out of my way. I just want to access your supercomputer and I know what to do. And then the bottom ones, the apps. Apps are really just a special form of software. But the app kit, the experts that want to take their apps, take their workflows, and put a wrapper around them, that's when they have the app kit. So just to toot our own horn a little bit, in the past few years, we've had over 5,000 app launches, $9 million invested in the program, and hundreds and hundreds of engagements with prospective clients on there. So let's talk a little bit now about why somebody would even care. Why would they want to use modeling simulation? We've got something, but many people are like, so what? And we've learned over the years that in general, when you're talking to somebody, in the past, I would go and say, hey, look, we've got these supercomputers. We've got so many teraflops. We've got so many petabytes. If you notice, I haven't shown anything about what we call speeds and feeds. And I'm not going to, because that's a technical thing that comes after the fact. Most of the clients and businesses that we talk to, they want to see this. They want an ROI. Procter & Gamble has publicly stated that for every dollar they invest in modeling and simulation, they get at least a $7 return in business impact. And this slide in itself, this message, we put all over the place because this is what really attracts the attention of the business owners, the decision makers, as to whether or not to continue to have a conversation and see where this would lead to us. So when we put that message out, that intrigues people. And then the next question that's usually asked of, okay, but what about me? Great, Procter & Gamble, but I'm not Procter & Gamble. So one of the things that we've done is talk about how this really works across a wide range of industries. And here's at least somewhat of an Ohio-centric list of industries that are important here in the Midwest. And we have case studies. We have clients in every single one of these industries. So we're talking to somebody and they say, yeah, I'm not in the food processing or agribusiness like maybe Procter & Gamble is. I'm in biohealth. Great. I'm in automotive. You know what? I've got a case study and I've got slides and slides and slides. So let's pretend for a second that I'm talking to somebody in the automotive industry, which is obviously very common here in the Midwest. The story that I would tell them, say, okay, I've got a case study I want to show you about the automotive industry. There's a little organization you might have heard of called NASCAR. They use us. They're one of our clients. So, and I'm not talking about a particular NASCAR team, but NASCAR, the organization themselves, goes and runs simulations on our systems to see how rule changes they're thinking about proposing will impact both safety and performance factors. And we've got a cool 2-minute long video of NASCAR R&D engineer Eric Jacuzzi talking about this, showing some of his visualizations and explaining how this really impacts. And they've been a client for several years of us. So if NASCAR can make use of us, well, great. But the story goes beyond that, because some of the engineers that are working with NASCAR, a company called Total Sims, that's one of our clients here in Ohio, has taken some of that workflow and some of that knowledge that they've assisted NASCAR with, and they've wrapped it up into an app on the AweSim platform called the FSAE app. It's basically a virtual wind tunnel. Formula SAE is a national competition of college students all around the country that they go throughout the year, and they create a team, they solicit sponsors, and they design within certain parameters a race car like what you see there on the screen visualized, that they then in the spring go and race around. So we've created a Formula SAE app, and I'll show you this a little bit later, that allows those students who are really sophisticated and want to do wind tunnel and virtual design testing, but don't know where to start. What they can do is they can go and they can basically just create their CAD files, upload them to our website. All of the hard stuff of meshing, configuring the solver, visualizing, and outputting is all done automatically behind the scenes. So they can focus just on the design and then the results of their design. So what that looks like, just to show you a screenshot, because when I go to the live demo, inevitably live demos fail, is they create a CAD file. They go to what you see here is a screenshot of the website where they would upload that geometry to the CAD file. They would say, okay, run a simulation, and then they'd come back a little bit later and they would see movies. These have been visualized in ParaView. They would see comparisons of drag, of lift force, things like that, of one run versus another, so they can see how changing one geometry versus another really impacts their design. This is in active use by half a dozen or so Formula SAE teams around the country, where these engineers are ones that are going to go eventually work for NASCAR racing teams. So we have a whole pipeline that we're engaging in this whole automotive industry. And I have case studies that are available on the AweSim website. I'll show you that in a second, of all these different industries, be it welding, be it racing, be it injection molding out there. So that really helps make the business case. And these are written in a business standpoint of what the value was of them. So let's dive in a little bit. Again, I'm going to skim over this pretty quickly, but at that point, people generally ask questions of, hey, what the heck is this? What is this really? You're shouting out terms like high performance computing and modern simulation. What does that mean? Well, the definition we use is just that modern simulation is gaining information about something without actually testing it. And HPC is just really high performance computers compared to what's on your typical desktop. So the problem is a lot of people say, well, I'm already doing this on my desktop. I have SolidWorks. I look at that and it works fine. And I can't tell you, time and time again, I've gone in to talk to a client and say, okay, what are your bottlenecks? And they say, oh, I don't have any bottlenecks. It's working just fine. I say, okay, well, walk me through a typical situation, what your engineers do, what your day looks like. And inevitably they say something like, well, I'll be working on my design for my CAD file, whatever, and I need to get it done by about 4 o'clock because I've got to set the simulation running on my desktop so they can run overnight, and the results of it can be ready by 9 a.m. the next day, so that when I come in, I can look at it, and I have then the business hours to tweak it and play with it and do something with it. And I say, you've got a bottleneck there. You're running it overnight because of your computational power. What if I could have you run that simulation over lunchtime? How would that change your workflow? And at that point, the lights go off in their head, and they just said, oh yeah, I do have a bottleneck. I've got this design cycle is dependent upon that computational limitation I have on my desktop package. And then we usually often talk about how they have pretty low fidelity because they can only have so much RAM on their systems, and they can only model at a certain mesh size and mesh resolution. So those are the kind of things that from a technical standpoint really make sense then as to this is why it makes sense to step up to running on supercomputers, running with a high performance computing. So what are some examples of what people do in this? Well, there's a list here of manufacturing challenges if we're talking about just the manufacturing industry. And people often say, well, I don't understand how it would translate to my specific thing. Well, let's say you have an issue where you do liquid flow in your business. Well, we have a solution right now that I can show that we visualize filling a container. So you can see how it's splashing, and you can see how changing your nozzle, because you don't want to go out there and play with your machine settings on your production line because you're losing production time. That makes sense to them. So this is where there's a conversation that typically happens with whoever I'm interacting with of what types of things they do, and here are some examples of things that we've done or our clients have done on our systems. So I apologize. I just realized I've got the slide here twice. I'm gonna just skip over that, but that's again the why on there as to why they're doing it. The bottom line is that hey, businesses need to do more with less, and what I'm doing here is all about getting started with that. I'm not trying to say let's jump in and boil the ocean, but let's get started. How do you kind of not bite off too much and get yourself exposed to it? So we got a list here of those case studies and people that use it. In general, there's a lot of big OEMs, tier 1 suppliers in these fields that make use of it. And there's a lot of case studies, and we're trying to push it down to the supply chain, just the smaller companies. And we know that they are just getting started on that. They've demonstrated their improvements over the years, but these smaller supply chain companies don't know where to get started. To kind of summarize and wrap up this whole, hey, what are the benefits? I usually end with one specific example, and I said, look, we started talking in this case with race cars. That's really high tech, really sophisticated, and everything. I'm going to end with something really, really low tech, and that is a plastic 5-gallon bucket. There's a company called BUA Corporation that's one of our clients that does nothing but make millions and millions of plastic buckets. And whenever they've got a client that comes to them that says, I want to tweak on a new design, a new handle, new something, they've got a process they go through. And that typical process was about a 37-week process that would, as you can see on here, very standard, would require create some tools, do some testing, modify the tooling because it doesn't quite get it right, go through this whole iteration of stuff until you finally have it ready at the end. We helped them with an app to virtually simulate a bucket, crush test, drop test, things like that. And as a result of that, they've been able to interject virtual testing into that process. And one of the important things I mentioned here is that we are not trying to, and we don't recommend that you replace your entire product development and testing workflow. It just interjects in there. There's very few organizations that have gone all virtual. It's very expensive, very challenging to do. We like to say, we want you to replace the first few, but still do physical testing at the end. Don't try to replace the whole thing. they've saved themselves 10 weeks on average, 38,000 per new bucket design, which is tremendous for them. And then they've talked about this in various forums, various interviews out there. So at that point, generally the people that are talking about say, that's great, I want to learn more. Where do we get started? And where we recommend people get started is what we call our workshop, our modeling leadership workshop. And this workshop was actually something that was donated to us as part of the cost share by Procter & Gamble. So Procter & Gamble, if you talk to Procter & Gamble, they basically consider themselves a branding company, a brand super company, where they are buying and selling off various other brands. So at one point they owned Pringles and they got rid of Pringles, and they're constantly acquiring and spinning off brands. They recently spun off Duracell, I think, for example. When they bring a new brand in, they want the leadership of that company they've acquired to learn about the Procter & Gamble way and efficiencies, and they want to make that business better. So one of the things that they've developed over the years is what they call their modeling leadership workshop. It's not very technical, it's very business. So I'm going to kind of explain it here over the next 10, 15 minutes. That gets those C-suite, leaders up to speed on this whole idea of modeling, simulation, supercomputing, which is very integral to Procter & Gamble's competitive advantage, and gets them started on that. So Procter & Gamble donated that to us. We've adapted that into a generic, non-Procter & Gamble specific thing that we found to be very helpful for people. So the premise behind it is that most people are not modeling experts. We have experience and resources that we can bring to the table, and we want to provide some principles and tips so that people don't have to learn and go through all the mistakes that are common in this, and really lower that barrier to entry and get up to speed. And the important thing that people don't realize is many people initially think that this is a technical thing. It's not. What it really is a variety of cultural, business, and engineering aspects that need to play together. People need to understand and leverage what those cultural behaviors are, how they make decisions with models, and then how do they bring in expertise, or how do they get their internal expertise up to speed. So this workshop presents this as a journey that is laid out like a kind of a subway or a metro, with their 6 stops on that journey. So when somebody comes in and goes through the half day or so workshop, what I'm showing you here is a summary of the whole workshop. They're gonna have a kind of journey where it's each stop they're going to have some work that they're going to do that's going to be personalized to them. So at the end of that journey, that workshop, they're going to walk away basically with a business proposal that's customized to themselves. So that far too many people go to training sessions and they learn all this stuff, and then they go back and start talking to their colleagues. The colleagues are like, yeah, but I don't understand how that translates to us, or how are you going to apply this to us? And they're like, oh yeah, well, we're going to have to think about that. With this workshop, people walk away with a very personalized business proposal that they can just put on somebody's desk and say, here's what we're going to do, or what I propose we do. So the outcomes of that is really, hey, how does this work? How can you utilize it? What are some possible projects that you can identify that you'd apply to this? And how do you find further resources is what it comes down to. So here is that metro kind of plan stop. And you can see we go from a foundation, A, B, C, D, E, F. Each step of the way, there's all kinds of icons, and you'll see some of these in the summaries I'm going to show here, of here's a principle that we apply to this. Here are some tools that are available. Some of these are Word documents or Excel spreadsheets, things like that. And then, hey, stop and customize that and develop your own plan, and take some time to do that. So let's look at the first one, the first stop, and I'll just have kind of a slide or two on each of these stops to summarize. So the first stop is this A stop of what we call the modeling foundation. And the idea behind this is that you have to understand this is going to drive cultural change. It's not just about hiring some people and saying, okay, go do something. It's really about incorporating this into your business decision making. So there's some slides and some principles associated with that. And then you can see basically these 3 pictures I show are just slides that I've pulled out of the bigger deck. There's a worksheet that they would, at the end of this, go through and answer some questions in the framework of their own business and fill out kind of, hey, here's some notes and some follow-ups that I want to do when I get back regarding this whole cultural change business decision. Okay, so the second stop, more than one way to get started, explains that you need to identify this compelling business need. You know, what is it that you currently need? Do you need to, sometimes you need to create a crisis of some sort, or you need to identify what is the job that can be done, what is possible. Again, don't want to boil the ocean, don't want to just go and say, oh, something will come up. But, you know, hey, let's really define something that is actionable, that is within scope, that you can say, okay, it's going to have some value to us. It really, far too often when we come in, we say, hey, let's do a toy problem, or let's just kind of demonstrate this. And people shut down and say, yeah, I don't have time for that. That's not going to, you know, maybe in the long term that might help, but I'm busy with real problems and real business needs. So let's identify something like that. What is a real business need that we can look at? The third stop is plan formulation. And this comes back, you've heard me say several times already, don't boil the ocean. But, you know, it's dream and plan big, but start small and simple. So you really want to identify something that's going to have a big payoff, but is not too overwhelming. Is, you know, you want to really pay the bills along the way. Don't go and say, hey, there's going to be a payoff at the end of this whole thing. Trust us. Show small steps. Formulate some sort of plan that will have those steps on it. Then we get to, okay, what is the actual action plan and the work processes? So embed this into a business plan, have, you know, kind of stages and gates where you've got milestones. You know, use the common business processes that you already use for project planning and working through stuff, and just interject this into it of, you know, what do you fund, what do you stop, what do you start, continue. This whole thing about crises, maybe you say, you know what, I'm going to transfer some funding from this existing project into this, because this is gonna work on it. And this is how we're going to fund it. This is who the decision maker is going to be. All that stuff needs to be defined. Otherwise, it's just going to be this nebulous thing that's sitting out there, and nobody has responsibility. Nobody has ownership of it. There's no funding allocated to it. So E, organization. This is where we talk a little bit about both the capability and capacity. So great, you got this plan, but hey, you need to invest. Do you train your existing staff members? Do you bring in some external consultants? You know, what's the good handoff between having, you know, engineering and tech experts and modeling simulation experts, and the difference between those? Because for many people, it's just like, oh, there's the IT guy, he's going to be able to handle this. No, that's not the way this works. You need to make sure you have the right skill sets and the right distribution and assignment of tasks and responsibilities amongst those. And then finally, at the end of this, the final stop, what we call the leader's journey. And this is really somewhat more looking inwards of, okay, where are you? Are you convinced of this? Where do you need to be on it? And what can you do? What behaviors can you adopt in your day-to-day business interactions that will help facilitate what has kind of been laid out of that? So we found, again, Procter & Gamble has used this time and time again. This is incredibly helpful. It really is a different way of looking at modeling, simulation, and education. In the past, you notice nowhere in here did I say anything about computational fluid dynamics or finite elements or meshing or things like that, because that all comes after the fact. That's a technical thing. Initially, this needs to be a business decision, a project. It needs to be scoped with that, or else it's going to fail. It can't be just some kind of guerrilla type, behind the scenes technical thing. Yeah, sometimes those work, but in general, that is not how you integrate this into a business and have it as part of your overall culture. So one of the things that then comes out of this is people who said, great, where do I start? I don't know. Is that good for me or whatever? So we've developed what we call a self-assessment handout. This is available on our website. I'll show you that here in a little bit. But the idea is that there's different levels of readiness for HPC in an organization. Some people are going to be much more prepared than others. And you can see that on the left-hand side, that we broke it into kind of 4 levels of disengaged, curious, engaged, or power user. So on the back of this handout is a 13-question yes/no of things like competitors are using model simulation and winning new business. You are interested in leveraging HPC to improve your monetization performance. You answer those questions, you add up the number of yeses, and that really tells you where you are at this experience level and what type of solution we might be able to provide from AweSim. And so here's kind of that table reproduced again, where if you are just curious, inquisitive, we might come to you with what we call an engagement program, where we come in, sit down for a day, help you through that whole looking at your project and your business and trying to figure out where this might line up. Whereas at the more extreme power user level, you're already doing this. Great. You know what? We'll give you some accounts. We'll get you access to some software, show you how to maybe create an app if you want to encapsulate something. And, wonderful. We'll help you. But it's really, we have clients on all these levels, and we work with them, and we want to be very responsive across the whole spectrum of people. So that's kind of the end of that presentation, but I want to go, I promise you some live views. I want to go ahead and show you that. And I've like all good presenters, I've tried to queue up things ahead of time. So here is the AweSim website, awesome.org. And if you go into here, into solutions, and scroll down, you click on one of these industries. So let's say automotive. Here's where those case studies are that I mentioned. So here's the NASCAR case study on that. Likewise, I believe if you click on about, you can come into here. We've got some videos on here. Here is our AweSim brochure that has some of the slides I just showed you. And then I think the self-assessment, nope, it's not there, sorry. I think the self-assessment is maybe under solutions. Nope. Here, was it services? Yeah, there you go. So here's that self-assessment brochure as well that people can use to answer the questions. So somebody comes in, they sign up for an account, and they log in. I've already logged in with a demo test account. And you see a variety of things. These are all different products that we have available. So one of the first things, if you're a power user, and I'll do this from perspective of a power user, you say, okay, you know what? I want to see what's going on with the systems. Well, we have a system status app that I've preloaded. This shows you what's going on with our different systems. This is something that's all information that normally would be available via things like a QStack command. We've got Nagios graphs on here, and you can do all the things you want to do on that. So then people oftentimes say, you know what, I want to see what's going on with my job, my kind of active job. So here we go. Here's where the delay in the live demo, you can see loading. We might have to wait a second. But again, this is the kind of stuff that most power users would have no problem looking at a QStat or something like that. I've got a job I've loaded up right here. This gives me all kinds of information about my particular job on there, and I can open it in terminal. I can delete it, look at stats of it. So the next step for a power user is just get out of my way. I want access to one of your supercomputers. So our oldest system is called Oakley, and if you click into that, this is where you can request nodes, certain number of hours, different types of nodes. So this is the equivalent of a Q sub to get an interactive HPC job. I've already done that on here.
Don't forget to increase the size of this.
Oh, sorry. Yes, thank you. I did it on the first one. I forgot to do it on this one. Thank you, Steve. There we go. Okay. Okay, so here's where if I want to launch a shell because I'm old school, I can do that. And this drops it. All of this is just JavaScript based, so I could do it from an iPad. I could do it from my Android smartphone. I can do it from pretty much any web browser. And it's a little sluggish because I think I've got so much traffic over the network with my screen sharing. But here we go. Let's go ahead and see if this will launch. This is an interactive desktop that I had running earlier. And yeah, I apologize, it is sluggish. We tested this extensively, but for whatever reason, the network just doesn't want to play with me today. We'll let that load in the background. Oh, here we go. There we go. So there you go. I am on interactive on a dedicated node on our Oakley supercomputer. I could do just whatever I want. Like normal on this node on here. Likewise, this is loaded. There we go. I've got an SSH terminal into the supercomputer as well. Okay, so the next step down is, okay, I don't need to have full access to the supercomputer. I just want to access a certain software product. So LS-DYNA is one that Honda likes to use on our systems. And normally, the way those users would do it is it would all be command line based. They would log into a command line and submit stuff. But we've created a LS-DYNA workflow app that they can just go in here. They can say, I want to add my simulation. I'm going to close out of this one because it's probably going to slow us down. There we go. And I'll close out that one too. I can add my simulation, maybe. And you can see I've got a list here of a name. I can say I want to run a certain number of nodes, certain number of cores for a certain time. And then I would upload my Dyna input file in this case. Once I upload and create that simulation, what you're seeing, each row is a different simulation that we've done. This one is not submitted. I could submit it if I wanted to. Here's one that failed. I could look at the output of that and see why it failed. Let's go ahead and look and see why it was failed. Probably we did something silly on purpose. There we go. There's can't find any servers. We probably deliberately messed up the license server for that. And then you can do things like download results. You can delete jobs. You can copy jobs. All of this stuff, again, is just lowering the barrier to entry, making it easier for clients to use our systems without having to worry about all the esoteric Linux commands and stuff that you normally would make use of. And this is all available, by the way, through that whole open on-demand product I mentioned. And then you've got the people that say, I don't know anything about LS-DYNA. I just want to go and simulate filling a container. You mentioned earlier that if I've got a fluid flow problem, I can look and see how different containers and different settings would work. So here's where we've got a toy demo app called Container Fill Sim. The idea, again, with this is that a client would come in and they would upload their CAD file for their container. And here you see they would upload the CAD file, and they would put in some information about different types of the fluid. What's the density of fluid, what the flow of fluid would be. Once they do that, and I'll show you what a container looks like in this sense. Here's an example container in the browser, and there you go. That's just a barrel with 3 openings at the top of that container. So once they do that, they can come into here and they can hit simulate, and the whole workflow of the app is going to automatically mesh that. It's going to do a CFD analysis of it. It's going to post process and visualize it. They didn't have to do any of that stuff, and they come back and they have a variety of results. You can see they've got animations, they've got screenshots, and they can analyze that. So this is exactly what we have with things like the Formula SAE app, which in the interest of time, I'm not going to show you because I already showed you some screenshots to that. We also have things, console apps. If you're familiar with console, we have a whole bunch of heatsink sims and stuff like that. So that's kind of the gist of everything that we offer. We have a variety of clients. Last year, I believe we had 40 different active industry clients make use of our systems over the course of the year. That's millions of core hours. We're always looking to expand. We're always looking for partnerships. So, anyone have any questions or comments, feel free to, reach out to us after the fact or now. I think I'm at the end of my 50 minutes that I was allocated. So Steve, back to you.
Okay, let me just remind people that they can go to this website and click into the chat window and ask any questions that they might have. So SIG-HPC education.hosting.acm.org/Ajax chat, and we'll hold for a few minutes since there's a delay. Give you a minute to log in and ask a question. Also, I should note that within a couple of days, I will edit out our startup in this and have this posted on YouTube, and I will post a link to that on the ACM SIG-HPC education website. So if you want to review this or share it with somebody else, you'll be able to do that. So let me go back here now and just make sure that see if we have any questions posted. So far, none. So I'll give it a couple minutes though. We're a few live viewers, so. Well, Alan, thank you so much for this. So as part of the training, the apps that you put together, you indicated you use OSU on demand. Is this something that typically you would do under contract, or is the clients do for themselves, or some combination of that? How does that come about?
Yeah, it is all contract based for the most part. That we have a standard service agreement. Clients come, they sign up, they agree to the terms and conditions of the agreement, and then they get access to it.
Okay. I also point out that I've asked Dave Hudak from OSC to give a presentation more on open on demand. That'll happen sometime in May, where he's going to emphasize what a faculty member could do who's trying to teach some of these simulation techniques, how they could use this to create apps of their own that they could use in the classroom. So if people are interested in that, you'll see a notice of that coming up in a month or so. Well, Alan, I've given time for questions. There don't seem to be any burning questions at this point. So let me thank you again for giving the presentation. I think it was very informative, and hope that this gets you some attention for some of the things you've been doing with AweSim and industrial clients. So thanks again. And at this point, we'll sign off, and everyone watch the website for the posting of this YouTube video and for future webinars from the HPC education section. So again, Alan, thank you very much.
Thanks for having me.